Welcome. This is the 15th tutorial of the second series. This chapter is on structures. Parts of an object can be arranged in a specific order, or parts can stand in specific relationship to one another if combined, and this delivers a structure. Constructions or arrangements of different objects according to a plan or pattern delivers a strong and safe structure for human beings. Structures will either give shelter, contain something, or resist some type of force. There are many different types of structures. We are going to discuss only 3 of these types. The first one will be solid structures, then frame structures, as well as shell structures. Here we see some solid structures. A mountain range can be a solid structure, a wall can be a solid structure, even some rocks can be a solid structure. There are many other types of solid structures as well. You can do some research on Google to find more examples. Solid structures are mostly made out of solid materials, although various types of materials can be used, and we can even combine different types of materials. We also understand that solid structures are mostly fixed structures. In nature, we'll see that a mountain range is a fixed structure, as well as a house or a bridge for man-made structures. A badminton racket is an example of a frame structure. A bicycle is also an example of a frame structure. Frame structures consist out of a variety of shapes and lengths. There are various types of materials that we can use to build frame structures. A frame structure can be used either as a fixed or a temporary structure. Think about the roof structure of a building or a spider's web, even a movable tent. Even a hard hat can be an example of a structure. A hard hat is a shell structure as well as a motorcycle helmet. Shawl structures are usually made out of layers and flexible materials, although this is not a norm. Various types of materials can be used in the production of shawl structures. Shawl structures can be used as a wearable, a fixed, or a temporary structure. Think about examples like an egg. It's also a shawl structure, or a dome on a theater. There are 2 types of structures that are commonly referred to. The first one is natural structures, and we see this in nature where we look at caves or birds' nests. The second one is man-made structures, like bridges or monuments made by man. Structures must be able to carry a weight and support its own weight without breaking. Structures can be built to span over a vast distance, like the Golden Gate Bridge in San Francisco, and structures are built to contain something like a milk jar, and structures can be built to house or protect its occupants like a house or a nest. Every mouse needs a house. With any type of structure, it is important to understand the following concepts that influence the structure. Firstly, the material it consists of, the purpose of the structure, what it is supposed to do, which forces has an effect on the structure, does it support or house things or people, what safety measures need to be considered for the structure, does the structure impact or influence the environment, and in what way, and is the structure permanent or temporary. Forces is another concept that influence structures. On this page you will find various types of forces. Let's discuss them briefly. A tensile force is forces working in opposite directions like stretching. Think about an elastic being pulled at both ends. Compressive forces is forces working against and toward each other like pressing, like a woman walking on high heels. Rotational or torsion forces are forces working rotational at right angles on a lever or fulcrum. We refer to this as torque. Bending forces are forces working downward onto a surface of a structure due to gravity, and this is caused by the load. Shear forces are forces working in opposite directions but past each other, like sliding. Think about an ice skater or figure skater on ice. A static force is a force created by a stationary object on a structure, and a dynamic force is a force created by a moving object on a structure. A load is the combined weight of an object that has to be supported by the structure. A balanced load, or also known as an even load, will have equal forces working in and on the structure, for example, a scale. An unbalanced load or uneven load will have forces of different strengths and values working in on the structure that will cause it to collapse. Congratulations! You have successfully completed the tutorial.